So this topic is going to be called solving trig equations. Why would you ever want to do this? A, because it's on tests and stuff, and we expect you to know that stuff. But also, there are applications of it in science, and most of these trig functions, they deal with like cyclical stuff like planetary orbits. They have a picture of a guy working on computers and sine waves and stuff like that. Oscilloscopes, all kinds of scientists do this kind of stuff. So solving trig equations. Hello, Mr. So-and-so. Applications of it, I suppose, in real life, a little more applicable than the idea of identities. Identities are fun, though. I think they invented identities just because they're like fun math puzzles, okay? So they say something like this: 2 sine of x minus 1 equals 0. That's a trig equation, and you're supposed to solve it, and you solve it just as if you're solving an algebraic equation. And these are pretty fun. All you do is, first thing, what you want to do with trig equations, what you want to do is you want to isolate like sine of x or cosine x, or so just like you get x by itself. In this case, you want to get sine of x by itself or something like that, and then there's an extra step. So in order to do that, I just add 1 to both sides, right? Add 1, and I get 2 sine x equals 1. So sine of x equals 1/2. And then you have to say, then you have to know the unit circle, all right? So where on the unit circle, if I were to draw, let's draw a unit circle, okay? If I were to draw a unit circle, I should just have one of these at my axis, I should just bring one up. Where on the unit circle is sine equal to 1/2? How many of these? At pi over 6, but more than one place. Not just, whoops, my arrow's going the wrong way. Let's try that again. No arrows. Pi over 6, very good. But also, sine is also positive 1/2 over here, right? Which you call what? 5 pi over 6. Very nice. So x equals pi over 6, or x equals 5 pi over 6. But then they want all the possible solutions. So this, every time I go around the unit circle and get to this segment, okay, or to this terminal ray, they call it, every time I get there, that's another 2 pi. So the way you write that, if they want all solutions, they'll say plus 2 pi n, or 5 pi over 6 plus 2 pi n. That's where n is an integer.
What about minus?
Well, if n is an integer, then I can go backwards or forwards, right? An integer is a negative or positive. So if I subtract 2 pi n, I get I get something, I go around the unit circle then. Also, if you were to look at the graph of this function, and you were to see where sine of x is equal to 1/2, there's sine of x, do you remember that? And I were to draw a line through there at x equals 1/2, what we're talking about here is all of these places, right? So this would be pi over 6, 5 pi over 6. The next one would be pi over 6 plus 13 pi over 6. This would be, what would that be? 5 pi over 6 plus 2 pi. So that would be 12, 17 pi over 6. 17 pi over 6. So if this is y equals sine of x, y equals sine of x, and this is y equals 1/2. So that's kind of a graphical look at what you're doing, okay? But you're going around the unit circle multiple times. But if they have one like with your calculator, where is sine of x equal to 0.3? And by the way, a lot of you guys got that one wrong on the test, because if they say sine of x, say you say sine of x equals 0.3, right? And they want all solutions between 0 and 2 pi. How many solutions do I have? 2 solutions. So why do you only put one answer? Yes, you can take the inverse sine of 0.3, and that will give you some angle in the first quadrant, but there's another angle over here in the second quadrant where sine of that angle is also 0.3, right? The y-coordinate is also 0.3. So the way you get that one is you would have to take whatever that angle that gives you back, or whatever angle this is, and subtract it from pi radians. Or if it's in degrees, you would have to subtract it from 180. So a lot of guys missed that on the test when I was grading. Okay? There's example 1. Example 2. You ready? Only 6 more to go. Example 2. Sine of x. Sine of x. I got it now. Sine of x plus root of 2 equals negative sine of x. And they say solve on 0 to 2 pi. What does that mean? What does this mean? So you want to solve
0, but doesn't
includes 0, but doesn't. So you want to go once around the unit circle, but not include the go to all the way to 2 pi. You want to you use 0, which would be the same as 2 pi, right? But you want to stop. So you're only going to have 2 solutions probably for this one, not infinitely many solutions like in the last problem. So in this one, you just solve it like you're solving algebra. You get everything on one side, okay? Plus sine x. These are kind of fun and easy, right? So you get 2 sine of x plus root of 2.
Wouldn't that cancel out though?
What?
Negative sine of x?
What? No. Yeah, you get 0 over here, right? And then now I'm going to bring this root of 2 onto the other side. So I get 2 sine of x equals negative root of 2. And then what? Divide by 2, divide by 2. And so the question becomes, where between 0 and 2 pi is sine equal to root of 2 over 2? So what are those 2 places? Not pi. Pi over 4 is positive. Sine is positive. So here you have a negative sign. Where is sine negative? Here. No, not there. Sine's positive there, right? Add here and down here, right? So those are the 2 places you want to look for. So you call these are pi 4s, right? So that's 5 pi over 4. Is that right? It's 5 pi over 4. Or what's this angle to here? Nice. That 7 pi over 4. Questions? Problems? If they ask you, so again on the test I didn't take off, but if they ask you for an angle between 0 and 2 pi, you want to give them back answers in terms of pi's, not in terms of degrees, you know, because I didn't take off if you put your answer, if you're supposed to give a radian answer, you gave a pi answer if you had a degree. But if they're talking in pi, you got to think in terms of pi. Okay, next example, 3 tan of x squared. Solve. 3 tan squared of x. 3 tan squared of x minus 1 equals 0. Who knows what to do? Guess. Guess and check. No, you can't use guess and check. Oh, let's use blue. Okay, I'll tell you what to do. You add 1 to both sides first. Because, again, I'm trying to get tangent by itself. So now I got 3 tan squared x equals 1. Then I'm going to divide both sides by 3. And then I get tan squared of x equals 1/3. Now what? Square root both sides. So now I have tan of x is equal to, you can't forget about the minus part here. Plus or minus the square root of 1 over 3. And if that doesn't look familiar, that's exactly the same as, you can take the square to the top, which is 1. And if I can't do much to the bottom yet, that, so far, you're like that. But now, I'm going to rationalize the denominator so it looks more familiar. Root of 3 over root of 3, which gives me plus or minus root of 3 over 3. Does anyone remember where tangent is square root of 3 over 3? Derek? At multiples of pi 6. Okay? So if it were just, so on the unit circle, there would be 4 places, right? Because it's every time tangent is either pi over 6 or negative pi over 6. So excuse me, every time tangent is equal to positive root of 3 or negative root of 3. So those, and all that, so you have a bow tie there, right? So all 4 places. And so you could call it this, pi over 6. What you should really call it is pi over 6 plus what, pi n or 5 pi over 6 plus pi n. And the reason for that, okay, you could list all the different possibilities, but how far is it from here to here? How far is it from here to here? That's pi, right? That's pi? And so to go around the unit circle infinitely many times, I would just keep adding pi to that angle, right? But to get from here to here, I don't have pi, so I have to start. So my other possibility is 5 pi over 6. Plus, if I add pi n to that, I get to there. If I add pi n to there, I get there. See that? Okay? So that's the way you would write that, as pi over 6 plus pi n, or 5 pi over 6 plus pi n. Yes? We're good on that? All right. Aren't these fun? It beats going to the dentist, doesn't it? Solve. I hope none of your parents are dentists, are they? Probably some are. Your parents are dentists?
My dad is, yeah.
Uh-oh. He's probably a good dentist, though. I didn't mean to offend him. Minus 2 equals 2 cotan x. So, who can tell me what to do? What do you think you should do first? What did you do first? What do you think you should do first? Huh? Yeah. Now, one thing you don't want to do, you don't want to do this, okay? Because everyone said, oh, you can just divide by cotangent of x and divide that by cotangent of x. That's kind of nice, right? Because that goes away, and then that goes away, and then I have cosine squared of x equals 2. Well, you can't do that, because what happens if you were to do that, you would lose one of your possibilities, is that cotangent of x is equal to something, okay, equal to 0 or equal to something like that. So you can't divide by a variable, otherwise you kind of lose one of your solutions. So if you have a problem like this, can I do this? Make it disappear? What you want to do first, like Bailey said, is get everything on the left side first. So you go cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. And then I could factor out a cotangent of x from both of those. Cosine squared of x minus 2. See what I did? See what I did? Okay, I factored out cotangent x from here and from here. And then either, did I mess up? I don't think I messed up.
Because
Cotangent x.
it should be negative 1. And it should be
Did I mess up the problem? I'm just seeing if I wrote it down. Cotangent x, cotangent minus 2. No, I didn't do it wrong. Where should it be negative 1?
in the right area, because you're subtracting 2 cotangent of x minus 1 cotangent of x. Oh, no, you're not.
No, I did it okay. I did it right. So, two possibilities, either cotangent of x equals 0, or cosine squared of x minus 2 equals 0, which means that cosine of x, let's just solve this little thing, equals 2. Cosine squared of x equals 2, which means that cosine of x equals plus or minus the square root of 2. And this is just cotangent of x equals 0, right? So, how about this? What do I get out of this? What's the range of cosine? What's the range of cosine? What's the biggest cosine could ever get? Bigger, not the cosine of an angle, but what's the range? What are the answers that I can get out? No bigger than what?
1.
1 and no less than
0.
negative 1, right? So what that tells you is that square root of 2 is about 1.4, right? 1.414, something like that. And so this is out of the range of, it's out of the domain of inverse cosine. So if I try to find out that, there's no solution, okay? Because if I try to plug in inverse cosine of square root of 2, I'm going to get an error out because it's not in the domain of the inverse cosine function. Over here, cotangent of x is equal to 0. Well, let's see, I know that tangent of x is equal to 0 at multiples of 0 and pi. So cotangent of x, right, because that's, again, on the unit circle. Tangent, so if this is a point 1, comma 0, right? Tangent is opposite over adjacent. And cotangent is adjacent, or x over y, right? So over here, I would have the point 0, comma 1. So cotangent, which is x over y, is and 0 over negative 1 is still 0, right? So cotangent of x is equal to 0 at pi over 2 and 3 pi over 2. But the way you could write that for all values, so that would be if they said between 0 and 2 pi. But if they said for all values, you could just write pi over 2 plus n pi. You understand why that is? Because every 180 degrees, the tangent is equal to 0. The cotangent is equal to 0. Okay, that was example number 4. 3 more. I told you we'd be done. How long have I talked so far? Right? 17. All right, so we're moving on to the next problem. So here we go. Solve by factoring. So sometimes you have problems that look like this: sine squared x minus sine x minus 1 equals 0. And they say solve. So if you see something like that, that should key you to the fact that that's probably a factoring problem. Uh-oh, I lied, I think. No, there's only, no, there are 1, 2, 3 more after this. Sorry, guys. Okay, so all you do is you factor this, okay? And it's like 2x squared minus x minus 1. So that factors to 2 sine x. That's a squared, not a 2. Times sine of x, and where does the minus sign go? Minus, no, that's a plus, right? Plus 1, and that's a minus, no, that's wrong. That's a minus 1, right? And that's a plus 1, okay? And then you just draw a little squiggly line, and you say that I'm going to skip a step. Sine of x equals negative 1/2, or sine of x equals 1. And so this is true at sine of x multiples of, so down here, right, at negative, or 5 pi over 6, and then at, that's called 11 pi over 6. So pi over 6, not pi over 6, 7 pi over 6, sorry. 7 pi over 6 and 11 pi over 6.
Why is it negative 1/2?
Because if I subtract, if I set this equal to 0, right, I get 2 sine x plus 1 equals 0. And then if I divide it by 2, I get sine of x equals negative 1/2. And over here, I just get sine of x equals 1, which only occurs at 0, and then again at 2 pi. No, that's wrong. It only occurs at multiples of pi over, actually just at pi over 2. So the way you could write this as 7 pi over 6 plus 2 pi n, if it's for all solutions. And then you would have to write 11 pi over 6 plus 2 pi n. And then again at pi over 2 plus 2 pi n. To get all of the, that would be all of the solutions. So that one actually has three different solutions. Okay? You're good with that? If you were here, I won't finish this next one. I just want to show you what you would do if you see something like this. 2 sine squared. I'll let you figure out these ones on your when you start your homework. 3 cosine x minus 3. I guess I can finish that. So you see how these are mixed up like this? How you have cosines and sines mixed? Usually if you have cosines and sines mixed, you want to change them all into one thing. What can I change sine squared into? What can I change sine squared into? 1 minus cosine squared. So you can rewrite this as 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. And then you simplify this. So you get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And then you can rearrange things so that you have negative 2 cosine squared x, so it looks more like quadratic, plus 3 cosine x, and then 2 minus 3 makes negative 1 equals 0. And now what I would do before I tried to factor this is I would multiply the entire thing by negative 1, which I'm allowed to do, right? I can multiply both sides by negative 1. So in that case, then I get 2 cosine squared x minus 3 cosine x plus 1 equals 0. And then I try to factor that, which I should be able to do, okay? And you should be, so that then it just turns into a problem like the last problem. So you see what I did? Okay? Because I don't like to factor when I have a negative something squared, so I multiply through binary. You can try to factor it, but it's harder to think about. So what would that factor to? Would that factor to 2 cosine x minus 1 times cosine x minus 1, right? Equals 0. Should I keep going? Do I need to keep going? You're good, okay? You can figure the rest out. All right, so then another thing that you might not have seen before is, what am I with? Oh no, this is the last one, the very last one, okay? So the next one, and I haven't seen this before either, cosine of x plus 1 equals sine of x. And so you might say, well, I bring everything over to the left side or something like that. Sometimes that works, but what was that?
I don't even know.
Actually, I'm going to show you my way of, now I'll show you the way they do it, okay? So the way they do this in the book is they square both sides, okay? And if you square both sides, I like my way better. I want to see if my way works, okay? So if you square both sides, you get cosine squared x plus, don't forget there's a middle term here. You have 2 cosines x plus 1 equals sine squared of x, sine squared of x. Then you get everything on the left side. This is a little plus 2 cosine x minus sine squared x, right? Plus 1 equals 0. Then I'm going to change this sine squared into cosine squared because I have too many of those. So I get cosine squared x minus, I'm going to write this as 1 minus cosine squared x plus 2 cosine x, oh my goodness, plus 1 equals 0. And then I'm going to combine like terms. So I get minus and minus makes a plus 2 cosine squared x. Then I'm going to have a plus 2 cosine x. And then I'm going to take this minus 1 and this plus 1 and put them together and make them disappear. Equals 0. See what I did? Who knows what to do next? 2 and what else? 2 cosine x times cosine x plus 1 equals 0. Right? So now I get that 2 cosine x equals 0, cosine x equals 0, x equals, where's cosine equal to 0? At pi over 2 and 3 pi over 2. Pi over 2. And then again at 3 pi over 2. Let's say that they're asking you for this answer between 0 and 2 pi. So that's a solve on 0 to 2 pi. Like that. Where is cosine x equal to negative 1? Where's cosine x equal to negative 1? You know, don't you? Pi. Very nice. Who said that? Very good. Taylor. Good. He knows his unit circle. Good. So x equals pi over 2, 3 pi over 2. Now, with this one, because I squared both sides, I risk introducing an extraneous root. Okay, so I have to check all my answers in the original equation. And so you have to take these 3 answers and plug them back in. So the original equation was cosine x plus 1 equals sine of x. And so if I plug in pi over 2 in here, so you really do have to check this. I get cosine of pi over 2 plus 1. So this is your check, right? So cosine of pi over 2 plus 1 equals sine of pi over 2. You're checking to see if that's true. What's the cosine of pi over 2? 0 plus 1 equals, what's the sine of pi over 2? No. Wait, sorry. Cosine of pi, oh, you're right. That's 1. So does this one check? Oh, does that check?
Yeah.
Yes. So pi over 2 is a root. But let's try it with 3 pi over 2. Cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. 3 pi over 2. What's the cosine of 3 pi over 2? 0 plus 1. What's the sine of 3 pi over 2? Negative 1. So does this one work? No. So this one is an extraneous root. Extra root, so you throw it away. And this one would work if you plug in pi. So the third check would look like cosine of pi plus 1 equals sine of pi. And the cosine of pi is negative 1, so you get negative 1 plus 1 equals sine of pi, which is 0, and that one checks. So my only solutions are pi and pi over 2, not 3 pi over 2. You throw that one out because that's an extra root. Now, I just want to show you, I think it's faster, and I want to make sure it works. Okay? My way. There's another way to do this, I think. So, what I would do is, can I do this? Oh, never mind. I can't do that. Never mind. I was thinking if there's a 1 on this, never mind. But if I were to divide by sine of x, right? Sine of x, I'd have to divide both of these. That doesn't work. I was thinking we'd get a tangent of x, but we don't. Never mind. Okay, so that's the end. And you can start on your homework. You have 30 minutes, half an hour, as promised, right? And I have, okay, there's your homework, which you can see right now. And this video took exactly 29 minutes and 51 seconds.
Oh, no.